Hi, for this video we are looking at solving another linear equation. This one is a little bit more complicated because we do have to simplify both sides. So both sides requires that we use the distributive property, and both sides require you to simplify. So the first thing that we want to start with is we want to simplify both the left and the right hand side. So for this one, what we want to do is we want to take this -3 and we are distributing this to everything behind it. We're giving that product to everything else behind it. The 16x, we cannot subtract these, number one, because this does not have an x, and number two, because multiplication is more important than subtraction. So let's start by simplifying, or by distributing the -3 into each number. So I have -3 times a +4. Since I have a negative times a positive, that results in a negative. So 3 times 4 gives me 12x. And then I would take the -3 and I also have to multiply it to the 7. So -3 times +7 gives us -21. We want to do the same thing on the opposite side. This time we're just distributing a negative. So we end up with 6x minus 2x minus 21. Both sides still have things that we can simplify. They both have like terms. So on this side, what we're going to do is we're going to go ahead and subtract the 16x and the 12x. So we're going to simplify it by adding the numbers in front. So 16 minus 12 gives us 4x minus 21. On the other side, we end up with the same thing because 6x minus 2x gives us 4x minus 21. Okay, so if we were to bring the 4x to the other side, when we subtract this, we end up with a special case. If I subtract the 4x from this side and the 4x from this side, they both cancel out. So we end up with a statement that -21 equals -21. Since this is true, -21 equals -21, this tells us that we have a special case where all real numbers work for this. So I could take any number and plug it into here and it would end up with -21 equals -21. Some textbooks call this infinite solutions, so you could also call this infinite solutions because everything in our number system, if you plug it in, will give you the same result. So if you end up where your variable terms both cancel out and you have a true statement, then you end up with all real numbers or infinite solutions as your final answer. So if I were to take any number and plug it in, it would work in this equation. As always, thanks for watching.